All right, so that should be working, hopefully.
Let me see. Okay, it works.
Great. Okay.
Have you received, Karen, have you received any reply from the next speaker, Mark? Mark?
I'm sorry, who was it? No, I haven't heard back from anyone. Do you want me to follow up on it?
Okay, then I will send an email to him again.
Okay.
Just in case.
Okay, yeah, and I will follow up.
Yes, okay. To switch.
All right, I'm going to share my screen again here.
Yeah. Ricardo is here.
Yep. Good afternoon, Ricardo.
Good morning.
Hi. Good
How are
afternoon, Ricardo.
How are you?
Hi. Yeah.
Karin,
Thank you very much.
Yeah. Karin, I just
Thank
sent you a message. Professor Maszek Gozalek was trying to do the registration and he did not succeed.
Yeah, I sent him an email on how to join.
You sent him an email?
Just now, yeah, I saw your email. Yep.
Well, thank you very much.
You're welcome. Yeah, I don't know what happened and why he couldn't register, but.
By the way, he was a former president of IEEE Secrets and Systems Society.
Oh, no kidding. Oh, boy. Okay.
Yeah. Yeah, he's also running now for one of the IEEE position.
Oh, no kidding.
Yeah.
That's a good thing.
Yeah.
Okay, where is Victor?
Yes.
Ricardo, I will spend about 1 minute to introduce something about the webinar.
Yes.
And I will pass the time to you. Is that okay?
For sure.
Yeah. Yeah, very, very short. I think 1 minute, then I will pass the mic to pass the time to you.
Okay.
So Henry, is this slide okay to start with?
Yeah.
Okay.
Yeah. Just say thank you, good afternoon, welcome. Yeah.
And Ricardo, are these slides okay? Did you have a chance to look at them? And I apologize, I forgot all about this until this morning.
Not yet. I'm trying to find them here.
Or you can just look on the screen. Sorry, Scott, you're seeing my
Yeah.
prep here. And that's it.
Yeah, they are okay. Yes, nice.
Yeah. All right, good.
There is only I sent you a message some time ago that in the publicity of the event, also here in the last slide, maybe it should be worked to put all logos of the societies in a similar size, no?
Yeah, you know what happens? So it's interesting on the website, and welcome, Victor. It's, believe it or not, the website is right. The way the spacing is, it depends on how long they are and how high they are, so they look different. Now, I may have messed it up on the slide because I did it quick this morning, but
Yeah, because maybe the height is similar, but depends also on how large is each logo, no?
right, right,
So we have to compensate a little bit to.
right. Yeah, well, look, I'll look into it again, but I know I asked our webmaster about it. And she said that, you know, honestly, it takes up the same amount of, I don't know, pixels or whatever. I'm not sure what the metrics are, but yeah, they're similar. So, all right. Good morning, Victor.
Good morning, everyone. How are you?
Hi, Victor.
Very good. How are you? Okay, would you like to try your slides? Just to make sure, I will stop sharing.
Yes, let me share that.
Hang on a sec. Let me change.
Okay.
Buenos días,
Buenos días, señor. ¿Cómo está usted? ¿Tudo bem?
tudo bem? Yesterday, the president lost his proposal to return to the printed vote.
So, what are you seeing?
Yeah,
The
perfect.
Yeah,
center?
perfect. Excellent.
Okay,
All good.
okay,
Yeah.
okay, good.
Yeah, we are very proud of the electronic voting in Brazil, no?
Yeah, but
It works
Bolsonaro
very
is
well,
proud of,
but
but Bolsonaro is proud of nothing, you know.
yeah, he was willing to return to the old times with the
Of course,
printed vote.
of course. Yeah, you have a big problem with your president in Brazil. You have to fix that, you know.
Yes, as soon as possible.
Yes.
Yesterday, the Minister of Education told also that the university is not for anybody. So,
Okay, okay. Why not?
yeah.
We are having too many crazy people in this war. That is one of the main problems. You know, I will agree with this Israeli writer Harari, who said that the humanity is the big problem. It's not the global warming. It's not the pandemic. It's the humanity. It's the people. That is the biggest problem in the world today.
Mashek will attend your talk.
Wow. Thank you. Thank you. I hope we will be able to meet in person by Lascas, or even
Yeah.
before, or even before.
Yes, Francois Rivet told me yesterday that he already bought the tickets to.
I know he bought the ticket and he is coming with Jan Deval, with Guillaume Ferré,
Yeah.
and maybe we are trying also to bring Christophe to Chile as well. And I hope we will be able to go to France for the CAS BOC meeting.
I'm going.
Through which country? How do you plan to arrive to France?
I'm going to Switzerland before,
Okay.
Anyway, we hope that the European Medical Agency will approve CoronaVac before that.
I hope.
But anyway, coming from a green country like Switzerland,
Yeah.
as I have no restriction to travel to Switzerland now,
Yeah.
I will go before and to see my grandson also. Finally.
Okay, good. Yeah, that's true. Finally. How will
Yeah,
he?
October 19 is his first birthday.
Ah, you have to be there, of course.
Yeah, I
I
must.
have to be in Bordeaux on October 22nd.
October
I have my
19, first
I have my
birthday.
thesis defense.
So we are in 3 minutes for the talk.
Yeah.
So, Henry, can you put your slides in presentation mode? Who is managing the slides, Henry or Karen?
It's
Karen.
Yeah,
Karen.
exact. So my problem is I can't see all my little chat boxes and things when I do that.
Yeah, it's in the bottom. You have the icon to
Yeah,
put in.
yes, there. Yes.
Better?
Yes.
Okay,
Yes.
thank you.
It's not perfect because there is some margin, but it's okay. So 2 minutes.
All right, so Henry, when you're ready to kick it off, let me know and I'll start recording.
Yes, sure. Okay. Okay.
It's very quiet.
Yeah, only right now. 5.
Yeah. We had about 100 registered, right? So
Yeah.
they're coming in now. And just a quick reminder for the panelists too, if you're not speaking, if you could just go on mute when we start, that would be great.
Yeah.
Yeah. Okay. Yeah. Sure.
I'm going
And
on.
turn off.
I
stop
forgot
video
as well, so thank you.
Well, it's already 10 a.m.
Mm.
here.
Okay.
Should we start?
What is okay to start?
I'm okay.
Yeah.
Okay. Yeah. Okay. Yeah. Let's start. Good morning, good afternoon, and good evening, everybody. This is Henry Chung, a member of the IEEE IoT Activities Board On behalf of the board, welcome all of you to join today's webinar. The Internet of Things is one of the most exciting technological developments in the world today. The key missions of the board is to promote IoT, and currently we have 12 IEEE societies joined it. With their support, we have this webinar series. Each month we have an exciting IoT topic. Today is the third one. We are very delighted to have Dr. Victor Grimblatt to deliver an interesting topic related to the use of IoT in a way to feed a growing population, and Ricardo to be our moderator. And thank you very much. I hope you can all enjoy this webinar. If you have any questions, do feel free to type your questions in the chat box. Now, I would like to pass the time to Ricardo. Thank you very much.
Thank you, Henry. So thank you everybody that is attending this third webinar of IEEE IoT initiative. So today we have the pleasure to have here Victor Grimblatt to give this talk about how to feed a growing population while conserving the planet's resource, IoT to the rescue. So Karin, can you, yes. So Victor Grimblatt is the Research and Development Group Director and General Manager of Synopsys in Chile. As you should know, Synopsys is one of the main EDA companies in the world. So Victor Grimblatt has an engineering diploma in the microelectronics from Institut National Polytechnique de Grenoble in France, and an electronic engineering diploma from Universidad Técnica Federico Santa Maria in Chile. Now he's doing a PhD on IoT for smart agriculture at IMS Lab in the University of Bordeaux, France. He's currently a research and development group director and general manager of Synopsys Chile, leader in the electronic design automation company. He opened the Synopsys Chile Research and Development Center in 2006, so it's celebrating 15 years this year. He has expertise and knowledge in business and technology and understands very well the trends of the electronic industry. Therefore, he's often consultant for new technological business development. He has published several papers in IoT, EDA, embedded system development, and since 2007, he has been invited to several Latin American conferences in several countries from Latin America to talk about circuit design, EDA, IoT, and embedded system. From 2006 to 2008, he was a member of the Chilean Offshoring Committee organized by the Ministry of Economy of Chile. In 2010, he was awarded as Innovator of the Year in Service Export. In 2012, he was nominated to Best Engineer of Chile. He is also a member of several technical program committees on circuit design and embedded systems. Since 2012, he is chair of the IEEE Chilean chapter of IEEE Circuits and Systems Society. Is one of the most active chapters in Latin America. And he is also the president of the Chilean Electronic and Electrical Industry Association. Since 2021, he's a member of the IEEE Circuits and Systems Society Board of Governors. So Victor Grimblatt was professor of electronics and IC design in Universidad de Chile and Universidad de Los Andes in Colombia. He's currently lecturing a course on IoT for agriculture at Universidad Santo Tomás in Chile. And Victor's research areas are EDA, electronic design automation, smart agriculture, applying machine learning, intelligent, and IoT. Victor Grimblatt is also the general chair of the next IEEE LASCAS conference, that is the flagship conference of IEEE Circuits and Systems Society, organized each year in a different location in Region 9. And the next, the conference will be end of this year will be, and next year will be beginning of March in Puerto Varas in Chile. Maybe Victor can say something at the end of his talk. So then just a few words about the IEEE Internet of Things. So it's the next slides. So the mission of the IEEE IoT initiative is to serve as the gathering place for the global technical community working on the Internet of Things, to provide the platform where professionals learn, share knowledge, and collaborate on this sweeping convergence of technologies, market applications, and the Internet, and together change the world. So the IEEE Internet of Things has a nice set of sponsoring societies from IEEE and councils. So the leading society is the Communication Society, and the sponsoring societies are Council on Electronic Design Automation, IEEE Sequencing System Society, IEEE Reliability Society, IEEE Signal Processing Society, CSS, EDS, IES, MTT, Power Energy Society, Power Electronic Society, and Solid State Circuit Society. So thank you very much to Victor Grimblatt to accept our invitation to give this talk today in a very hot topic nowadays. So I give the floor now to Victor to start his presentation. By the way, if you have questions to Victor, you can write the questions in the questions and answer, and the questions will be read to Victor after his talk. So Victor.
Okay. So thank you very much, Ricardo, for the presentation, and thanks for the invitation. So I'm starting to share my screen, and one of the most typical questions today is, are you seeing the right presentation? Is that okay?
It's okay, yeah.
Are you seeing the presenter mode or the presentation mode?
The presenter mode. The presentation mode, it's okay.
Okay, thank you. So as I was saying, thank you very much for this invitation and for your presentation. So let's try to move into the topic is how to feed a growing population while conserving the planet's resources, and IoT to the rescue. So this work is part of my PhD thesis that I'm doing at the University of Bordeaux. So I'm trying to present first the problem, why we are so interested by this problem. What are the main things we are trying to fix? Because in my opinion, just making IoT per se is not giving any benefit. We need to be able to solve a specific problem. So after I will give a couple of slides, 3-4 slides about some IoT main concept and architecture, just to remind that. And I will go to the topic of improved soil productivity and some conclusions. So the problem is, okay, so I started a long time ago putting some plants on my countryside home. So I was irrigating them and continue irrigating and looking for the plant to grow. I was having some tomatoes, some lettuce. And by the end, I found that despite the fact that I was irrigating in the right way, nothing happened. So the plants, my tomatoes died, my lettuce died. So as I started to investigate the problem, and I found that plants need more than water. So just water is not enough. And we will see that a lot of IoT systems today dedicated to agriculture are just thinking on measuring humidity, moisture of the soil, and irrigating when it is necessary, when the system is saying go and irrigate. But plants need more than water. So my first investigation found that plants need nutrients, water. We have to take care of the pH of the soil, the temperature of the soil, the texture of the soil, the salinity, and I will give some details about that, the weather condition, the environment temperature, and so on, the light that the plant is receiving. So it's a very complex problem. And why is so important? So the first one is the population is growing. We are expecting to have something like, I don't know, 9 billion people over the world in the 2050, more than 10 billion at the end of this century. So the population is growing. So we need to feed more people. But on the other hand, the arable land, meaning that the land that is dedicated to agriculture, where we are getting the food, is going down, is decreasing. So we see there that in the 60s, in average, we were having 0.5 hectares per person. Today we are at 0.2. So we are decreasing the number of the available land for crops. And the reason is there are several reasons. One of the most important is the cities are growing, because we have more people going to the cities, leaving the countryside, going to the cities. So cities are growing. So we have less land. On the other hand, we have the climate change, and we just read, and I will give a couple of details, the report that was coming from the United Nations this week about the critical situation we are living, and it's mostly not reversible. So the climate change is a major challenge for agriculture. Its impact is caused by rising temperature and associated climate phenomena. Short term, we will have greater climate variability, extreme events. In the long term, shifting mean climate conditions, and agriculture is one of the most climate sensitive sectors. And this is part of the report we see in a couple of days ago, temperature increase of 1.5 to 1.6 degrees centigrade by 2030. It was expected to be by 2050, now we're by 2030. Saturation of forests, soil, and oceans in CO2 absorption, meaning that they are not absorbing CO2 anymore. Global warming produces severe weather conditions, rapid sea level rise. And yesterday I was listening to someone who told that the island countries are complaining because even with 1.5, they will be something like a meter or 2 meters of the sea level rise. So they are complaining about that they will be very impacted. And the methane is the second greenhouse after CO2, the methane, which is CH4. And on the other hand, if we look from the economic point of view, there is a very interesting theory coming from the economist Kate Raworth that created this donut economy in 2012. And she said that the economy has to be limited, the growth of the economy has to be limited by the upper limit and the down limit. The down limit is the social foundation based on the United Nations Sustainable Development Objective, and the upper level is based on what is called the planetary boundaries that was created by Joan Rockström from the Stockholm Resilience Center in 2009. So you see here, I will try to put that in that way. So let me try to put my laser pointer. So climate change is there, land conversion, biodiversity. So we see that agriculture is impacted by several of these planetary boundaries. And where we are in red, it means that we are over the capacity of the planet. So 1/3 of the global gas emission, the greenhouse gas emission, is caused by agriculture, forestry, and change of land use. Methane from cattle, manure, land conversion to agriculture, and it is very critical what is happening in Brazil, and I have discussed that with Ricardo several times about the Amazon. The reason that the fact that we are losing a lot of trees in the Amazon is producing a big problem, not only for Brazil, but for the world, because the Amazon is a place where CO2 was captured by the trees, and converting that to agriculture, and in any way, it's producing a lot of problem. 47% of this 1/3 gas emission is coming from land conversion. Ecological footprint, I read that last week we were already having one planet resource. So by July, we were spending almost all the resource we have for the year. So we are going to approach the two world resources by the end of this year, probably. And we need to make a big change so we can go back to some place where we are not using or overusing the world resources. So, and on the other hand, for 2050, current agricultural production needs to be increased by 70%. So we need to increase because we have more people, we have less land to do that, but we need to increase the agricultural production by 70% by 2050. Fresh water is another problem. Agriculture is the heaviest consumer of our planet available fresh water. 70% of blue water withdrawals from water course and groundwater are destined to agriculture usage. We always think that industry, mining companies it's using the water. No, it's the agriculture. And we see that in several places of the world, in South Asia, for example, 91.2% of the water is going to agriculture. In Middle East and North Africa, 85%. Sub-Saharan Africa, 80%, Latin America, 72%, and Europe and Central Asia is 35%, which could mean that they are better organized on the water usage. But in all this part of the world, we see that there is not even water for people. See, the domestic part, for example, here is very small. So there is not enough water, but the water is used by the agriculture. And one of the last, I would say, problem we see is the global land use for food production. We see that finally we are using a very small part of the land for food production. So 77% of the agricultural land is used for livestock, meat and dairy, and 23% to crops. However, the crops are giving us more calories and more proteins than the meat, but we are spending more land and more water and more problems on the livestock. So we'll have to analyze that as well. And the last thing I want to say on this problem is the farmers' distribution. 80% of farms operate on less than 2 hectares of land, so very small. So we are talking about about 500 million farms smaller than 2 hectares. So the majority of the agriculture is based on a small to medium farmers. In the poorest countries, 70% of land is operated by farmers smaller than 5 hectares. Small farmers are not adopting technology. So when we talk about the IoT and technology going to the agriculture, no, it is only true for the big farms. But the small farms are not adopting. It's too expensive, hard to use, digital skills, communication availability and cost, and we are going to talk a little about that in the next minutes. So we have a big problem. More population to feed, less arable land, climate change, less fresh water, ecological footprint, low cost, low power, easy to use, able to communicate. How to solve this problem? And there we think that IoT could help. It's not the solution, it could help. And the agricultural dilemma is increased productivity versus planet boundaries. So how we can increase the productivity without continue to affect the planet boundary. And this is what we say, the IoT to the rescue. So let's go now to understand a little what is IoT and how IoT can help to solve one of those problems, because there are too many. So main concept and architecture, what is IoT? I don't want to give the typical sentence about IoT, but for me, IoT is the connection of the physical world to the digital world, meaning that I will be able to take data from a lot of things and able to process this data, to analyze this data, and to define actions and to make action based on this data. This is my main definition, and it's coming from myself. That's why. So things, what are things? Whatever you want. I just took some examples of the agriculture or food things. So we have a cow, we have a flower, we have some vegetables, a container where we put things, a factory where they're processing food, the aquaculture, salmons and the trees and ships, because sometimes we are transporting food on boats, on ships. So the IoT market application that exists, the smart home, the connected vehicle, the smart cities, wearable infotainment, health and fitness, and the one that is interested to us in agriculture is what we call the industrial IoT, IIoT. And this is the one that we are going to talk. So the first thing, I don't want to give a big detail on IoT, but how to connect a thing to an internet. Because for us, we are talking about things that are like fruits, like lettuce. So how to connect that? So we are going to put sensors and we are going to connect those sensors to a node or an edge. And we are going to transmit this data through radio link, because do not forget that you don't have internet in all places, and in the land you don't have internet. You connect that to radio link, you concentrate your data, and through a network link you transmit that to the servers and providing information to the end user or doing some statistical study. So how to transmit with what we talk about radio link, network link. So what are the different options and how to choose? So in general, the communication system that can be used in this kind of application are based on distance and the quantity of bits I want to transmit, the size of the information. So if we think on Zigbee or Bluetooth, therefore, okay, distance is very short. And when we are talking about the smart agriculture, we are talking about sensors and nodes and edge that will be connected maybe a couple of kilometers from the place where I have the gateway. So I need to think on something that could be low power, low cost, and also go to big distance. And this is what the reason that we use in IoT for agriculture, low power wide area like Sigfox or LoRa. Those are the selected and the main communication system. You can think, but why you don't use cellular? It's so common. So there is two problems with cellular. The first one is the cost, and the second one is the cellular availability. There are places, not only on underdeveloped countries, but worldwide, there are places that you don't have internet, and this is mostly on the countryside. There is no internet at all. And people are saying 5G is the solution. Yes, but we have first to install the infrastructure to have 5G. And I have visited several places where you don't have any kind of signal. Okay, so this is the reason that we prefer to think on low power wide area as the solution for the smart agriculture application. Where to process the data? We have the cloud. It's only convenient when action is not immediately requested, but it can produce bandwidth issues and cannot send all data to the cloud, no changes. Let's assume that, for example, we are measuring the temperature or the humidity of the soil. The humidity of the soil is not changing very often. So we have very small changes. So do we need to send all the data to the cloud for analysis? Maybe, maybe not. This is something we need to define. Gateway is useful when having a sensor network, but edge is becoming the most common place to process the data. It's very efficient and needed for fast action. Of course, we need to define what is fast action when we are talking agriculture, but because of the problem of bandwidth, latency, amount of data, we don't want to overload the network. So even in agriculture, when the need for fast action is not really existing, we prefer the edge computing anyway. So edge computing refers to the computation and analysis of data on distributed devices positioned at the edge of a network-rated and uncentralized system. And according to Gartner, by 2025, 75% of data processing will move to the edge. It was 10% in 2018. So this is the typical edge architecture: battery, energy harvester, if needed, sensor actuators, software, processor, storage, and the communication way. What are the main problem today? The opportunity with hardware. So the battery life is expected to extend while adding connectivity. It is true that we can put some energy harvester in the nodes on the edge, but for agriculture, sometimes it's the cost of the solar panel will be too expensive. So we prefer to reduce the power so we can live for 2, 3, 4 years with just one battery and no recharge. Type of functionality, connectivity, and energy use dictate cost. We are talking about the small farmers, so we need to be very, very low cost. Integration, wireless power management, memory, sensor, processor. So there's a lot of things to do. And security. Security is very important, even in the agriculture, as I will show in a couple of slides. So just to give an example of power management. So we need to take care of the power. It spans software and hardware. So we have to be to take care of when the sensor will be active, the frequency of data collection. Are we going to collect data every 10 minutes, every 30 minutes, every hour? Wireless radio communication, strength and power, frequency of communication, microprocessor, microcontroller power as a function of core frequency, passive component power, energy loss from leakage or power supply inefficiency, power reserve for actuator and motor. So if, as I say, if we want to do, for example, we want to have an edge that will be alive for 3 years without any human intervention, without changing the battery, we need to be very careful with power and we need to manage the power. Agribusiness threats. So even in agribusiness, we have problem with the security. So FBI already identify agriculture as an industry with cyber risk. IoT device and sensor are the most dangerous and need protection. And hacker or cyber criminal can access farm data to predict market availability and price. And this is one of the main problems: predict market availability and price. Malicious actor could sell farming information to competitors. And information supply chain can also be vulnerable to cyber attack. So productivity, this is my research work. So as I say, there is a lot of parameters we have to take care. So important parameter from plants grow. There is the soil parameters and the environment parameters, moisture, nutrients, pH, salinity, conductivity, temperature, texture, light. In environment, we have the light, the temperature, the environment temperature, the humidity, the weather, etc. Some people are also we are also have to take care of the wind because it affects also the evapotranspiration of plants. So I'm proposing that we have to find an equation or a model of the yields of the soil, and this is what I call SY. That will be a function, and I don't have yet the function of the different parameters I already present. And the question we are having today, and we are researching on that, is that a linear, polynomial, exponential function. And the other problem is impact by a species. So the function for a lettuce is different than the function for a tomato or for the basilic. So we cannot have, or we can add an additional parameter to the function, which is the species. What is the importance of each parameter? So what will be the weight of each parameter on the growth? How interrelated are they? Machine learning algorithm, are we going to use supervised, unsupervised? And are we able to do a SPICE model for simulation? I will give some details about these SPICE models I'm also working on. So the texture corresponds to the amount of sand, silt, clay, and organic matter. So affects how good the nutrients and water are retained in the soil. So you can be irrigating, and if your soil is, I think, it's too sandy, you will have to. So there is more. So the plants can get more water, so you will have to irrigate often. And if it is a clay, you will have to irrigate less than on sandy, etc., etc. So it doesn't need to be measured, but this is an important data to the IoT system we are working. The moisture of the soil is the most common one. Everyone is measuring that. There are very good sensor, very low cost sensor, and by the way, the moisture are found in the market, the sensor. But one important thing is that the amount of water needed is based on species. So lettuce need, and not only on species, but also on the time on the grow. If you are just starting with a lettuce, it needs less water than at the end. Nutrients, there are chemical elements 16 that are important to plant growth. The main minerals are nitrogen, phosphorus, and potassium, known as NPK, or the minerals, etc. So we need to measure the NPK, and it can be measured based on the optical reflection characteristic. And we have produced a sensor of NPK using 3 LEDs, because we have found that if we send white light, the reflection, if it is on the blues, so we have more nitrogen. If we are going on the green, we have more potassium. We have more phosphorus and potassium. So we can make a sensor for this kind of thing with just white light. And this is the way that they analyze the land using satellites or drones. It's based on the reflection of the light. The pH, the problem is we need to measure pH on a non-aqueous solution. So it's also affect the availability of nutrient in relation with plant roots and microbial activity. So it could be a resistant if we sequence spice. So that could be a resistance. Okay. In situ sensor low cost not found so far. So we are working on that. Should not change very often. It's an assumption, but you can change the pH of the soil with the irrigation. It depends on the water you are sending. Nutrients availability, so that is so important because the nutrients are mostly available at a pH of 7, but if you have a pH of 4 or 5 or 6, it's not good. Soil temperature, so it's also a major storage for heat, like a capacitor. We are thinking on this SPICE model. Govern physical, chemical, and biological process, and it's also very easy to measure. There are a lot of sensors for that. Salinity is a problem because salinity could be increased by over-fertilization, irrigation, and water in industrial ways. And under extreme salinity condition, the plants may be unable to absorb the water. So you can irrigate, and the plants will not absorb the water. So it's plant and time dependent, and of course it's dependent on species. Data acquisition from the environment temperature, so we have the temperature and humidity, the weather, the light, and so that can be measured. So what we do with that? So we have been starting to do some experiments on an Arduino, and because of the pandemic, I was working in my balcony instead of being on the land. So I was measuring the soil temperature, and you see that the soil temperature is following like a sinusoidal wave. But I will also measure, this is a 4 days measuring, so you see that the moisture of the soil is changing. It is on a wet situation and move very fast to a dry situation and stay there. And here I have another interrelation between the soil moisture and the soil temperature. So we see that there is a transition part which is here going from from wet to dry, and what are the temperatures that are related to that. So this is part of the work I'm doing to interrelate those parameters. So my proposed solution is an IoT edge composed by an SoC and a communication chip, LoRa, able to capture data through sensor, acquire external data through a communication channel, to process the data on the edge, to act based on received data to improve soil parameters, to use machine learning techniques to improve the soil yield, to generate alarm to the farmer, and to transmit data to the cloud for further analysis. It has to work on real time, work on rechargeable batteries, but now we are considering one-shot battery, low power, low cost. And why edge computing? Because of real-time capture, analysis, and action. Communication availability in rural areas, too many data to send, so bandwidth and speed issues, and has to be low cost. So this is the overview of my edge. Okay, this is the architecture where we have the sensors, we have other inputs, we have the SoC, the LoRa chip, and the actuators. That was the first prototype I did. So it's based on a ARC EM starter kit from Synopsys. So with all the sensors. And now I'm working on the SoC. This is the current development of the SoC. This is the layout of the SoC, where we are having some part of standard cell, data memory and instruction memory. And this is the schematic. And right now I'm adding the paths to prepare that for manufacturing. Some conclusions on that. So agriculture provides our food. Population is growing, so more food is needed. Arable land is decreasing. We need to improve the soil yield without affecting the planet. Precision agriculture and IoT is the key. It is important to consider all relevant parameters and their interaction. We cannot just leave measuring moisture. We have to consider the other things. For example, fertilization is very important because the nutrients are an important part of the crop's life. We need to work with low-cost sensors, but unfortunately, they are not. There are only low-cost sensors for temperature and moisture, but we need low-cost sensors for the other parameters we need to measure. Machine learning will allow the IoT system to work independently. There is another thing I have not put here. We also have to work in situ real time, because there are a lot of IoT systems that work on tractors or engines that go to the land. But if we consider that, so if we consider small farmers, sometimes they don't even have a tractor. So sometimes they don't even have this kind of engines. So we need to have those kind of sensors that can go directly in situ. So machine learning will allow the IoT system to work independently. Artificial intelligence will provide algorithms to improve the yield and need to work close to agronomists. Okay, thank you very much. So I will stop sharing that. Okay. So we can start the, yeah.
Thank you very much, Victor. So you can do your questions using the questions and answer window, but you can also use the chat window. So we have a question from Jong Jin. Why real-time information is important in the agriculture scenario, given all info seems not time critical?
Yeah, you are right. It's not critical on time, but it's critical on communication because that we cannot send sometime that to the cloud to make the analysis and so on. It is much better to work on real time in situ. It's more an economical problem than economical and communication availability problem than anything else. So it's not because we need a fast action, but it's more that it is complicated to send data to the cloud to get actions. This is the reason we do it that way. I hope that was I have answered the question.
Okay, thank you, Victor. There is another question by Pat Scallan. How is progress on sub-oil sensor? Radio reach a few inches below the surface, Sigfox or LoRa?
Yeah, that is a very interesting question. So far, we are working, we are wiring the sensor to the edge, and the edge is transmitting. So I have not tried the subsoil sensors. I have not tried to have the communication directly in the sensor. The way I'm doing that is, so I have an edge that is not subsoil. It's on the land, so I can so I connect the sensors through wires to my edge, and the edge is the one transmitting through the LoRa network.
Thank you. So a question by Douglas Datwheeler. Thank you. Why is only one radio technology emphasized, LoRa? I would expect that radio would be evaluated by the end user.
Yes, a very good question. The reason is that as we are working with small farmer communities and there is no skills for this kind of thing, we are proposing LoRa because I have been making most of the tests in Chile where 6FOS is not very well implemented, and LoRa can be implemented very easily. That's the only reason that we are preferring LoRa instead of 6FOS, but both of them can be used.
Yeah, but Scallan is commenting that I believe a Sigfox type was designed at the University of Chicago a few years ago for subsoil.
Okay, thank you, Pat. I will investigate about that. I was not aware about that, so I will investigate that. Thank
you. A question by Sandeep Dayal. Soil nutrient is checked after fertilizer use to measure whether there is improvement?
No, so nutrients should be measured in the same way that moisture. So should be measured, let's say, every hour, and based on the availability of nutrients, we should define the fertilization of the soil instead of, because today farmers are fertilizing based on what we call the ancestral knowledge, what they learn from their parents, their grandparents. So today, what we are proposing, no, do not fertilize, and we are making some experiment on that. Do not fertilize. Wait for the system to tell you there is not enough available nutrients, so you have to fertilize. And in the next version, what we want is to fertilize through irrigation, and it could be completely automatic. So we are going to measure the nutrients, and if we see, for example, that one is missing, we can mix this nutrient into the water for irrigation, and then at the next irrigation cycle, we are going to fertilize the soil with this specific nutrient. And also, we have to be able to measure the amount of needed fertilizer, because if we are able to measure the nutrient, we can also define how much fertilizer we have to put into the soil.
Thank you. So a question by Sarah Kidden. Are you working with a specific community in this research? If yes, how are you working with them? What role do they play?
Yeah, we are working on with a specific community. We are working with some small farmers in Chile, and also the community of the agribusiness. We have created a special interest group in CAS about agri-food. There is an experience also in India where we work with a specific community. But the main idea is not only to arrive with the system to the community, but also to teach the community how to use the system, what is the importance of the technology, how technology can help them. Because from the farmers, the small farmers, they don't trust technology. They say, no. My father teach me that, so I have to do it that way. Technology will not change that. So we have to work with them. We have to approach the communities. When you work with the small farmers, it's not like you are going to one per one. So they are normally associating small communities per area, and we are working with this kind of association to implement the technology. And another important thing is to learn from them. They have a lot of knowledge. They know a lot of things that we don't know. So, and this is one of the things I'm presenting very with a lot of interest in my research work, is that if we just measure things without understanding from farmers and agronomists how the plants grow, live, and so on, we are not going to get any result. Let me give you an example. So I was planting some lettuce, and I was checking the irrigation, I was checking everything. But my lettuce died because birds come to eat the lettuce. So there is another parameter to consider for the lettuce grow and the productivity of the soil with lettuce is, what about if birds arrive to eat that? There are some other parameters that we are not even considering. So we have to work and learn from them, because so farmer will tell me, yeah, birds are coming in the morning. So maybe you have to measure that in the morning and do something in the morning, because they're not coming in the afternoon. Birds are only coming in the morning to eat the lettuce. Other things is, if you have if the weather is too cold and there is a frozen land at the time that trees are flowering, you are going to lose your production. So what they do is they cover, or they take big fans and send hot air to the soil, so they change the conditions. So this is the kind of thing you learn from the farmers and from the agronomists, and you can implement those things in your IoT system.
Thank you. So another comment by Pat Cullen. Also important to measure runoff the soil. For example, phosphates, and this pollutes rivers, etc.
Yes, you are completely right. And what we are thinking, if we are able to control the fertilization, we will be able to control in some way what is happening with rivers and so on. So it could be a consequence. So this is the way we are considering that, but it's very important what is happening. And this is also very important to consider the texture of the soil, because based on the texture of the soil, you can have more lixiviation, so nutrients can go farther to the ground water and go into the rivers after. So this is the reason that also the texture of the soil is so important.
Thank you. Another question by Renzo Barraza. Are these possibilities to use the IoT to measure the carbon capture capabilities of plants?
I don't have an answer. I need to investigate that, so I don't have an answer. You know, the easy answer is say we can measure everything if we have the right sensor. So the question would be, what is the sensor to measure that? I know that there are some research on that domain made by some universities. I think people from Italy are working on that as well. In Torino, they're working on analyzing the plant from another perspective. Yes, we can, but we need to be sure that the sensor is available. When I started my work, I was thinking that all sensors were available, and I found that this is not true. So the first thing to consider every time we want to measure something and to take an action is, do we have the right sensor? Do we know how to use it? Do we know how to connect this sensor to my IoT system? Do we know how I can act? So this it's like pH. Today we cannot measure pH. But the second question is, okay, if I am able to measure pH, how can I change it? How can I change the pH of the soil? Salinity is the same. How can I change the salinity of the soil? So there is one thing is to clean the soil. You can clean using water. You can change the salinity, but it's a very long process. So one thing is to know how to measure that, and the second one is how to process that, and the third one is how to act based on the results.
Sure. Sandeep Dayal has a question. Is there any estimated projection on how much of agriculture yield is improved by using this method?
Very, very good question. And I'm now working with an agronomist at Universidad Santo Tomás here in Chile, and we are making a test. We're making an experiment. So we are going to have, it's based on orange trees. So we are going to have one part of the land using the normal way of doing things, the ancestor way. And on the other one, we are going to put the system, and we are going to compare the productivity of the soil. And how to compare the productivity of the soil is also very complicated, because what do? We count orange, we count the diameter of the tree to see the growth of the tree. So we are working on that, and we hope to have some result by the end of this year.
Thank you. So I see no more questions in this moment. So if anyone has still a question, please do it as soon as possible. So I have a comment questions to Victor. Yes, it appears to me that, as you told, agriculture is an application that is a field that we don't need many cloud processing. So it would be better to have local processing, and having local processing to have also a reduction on the costs. It appears that to put all the electronics and computing in one chip to distribute it to farms around the world, and some farms are far away from cities, so with some connections problem. So how you can manage to put all much processing as you can in a low-cost processing system in maybe in just one chip, and so there is a large opportunity here for microelectronics now. And but still you need some communication to, for example, to have forecast. So we are not going to irrigate the plants if it's going to have a rain few hours later. No, so how you can divide this?
So what we need, and this is the reason we need a system that is able to communicate as well. So what we need is, okay, I'm designing, I showed the SoC I'm designing that could handle all the sensors, or at least an important part of them. So my chip will have different interface to be able to connect with different sensors and actuators, I2C, SPI, UART, and so on. And unfortunately, today, if we put inside the chip, the communication part, we don't have access to the low range, to the big, to the big range, low power, big range of methodologies like LoRa or Sigfox. And we need to start a discussion with them to integrate their part into the same SoC. And the information coming from the weather station will have to go through the gateway, because the gateway is connected to the internet, so we can get information from the weather station and send, and we have to create that protocol and send information to the edge saying, okay, it is going to rain in 5 hours. So consider that, or the wind is going to increase in the next 6 hours, because in that case, the evapotranspiration is bigger. So we need to make a system that is based on this kind of communication, but it's also have the intelligence to connect to different parts of the internet and provide data to the edge. But there is an important, but it's not only on that. I think today microelectronic is, and chip design is important in almost all fields. We were having 10 years ago, or 20 years ago, a good time where with microprocessor we are able to do everything. And electronic become almost a commodity, microchips, a commodity. You can find. Today, artificial intelligence, people are doing their own chips. Agriculture people are starting to do their own chips. Automotive people are starting to do their own chips. So we are going to a situation where microelectronic is becoming very important on the applications of the technology.
Yeah, also putting everything in a chip, we are reducing power consumption. No?
Yes.
That is
Yes.
a major point. So I'm not seeing any more questions here in the chat or.
No, there is
or
one. Have you
questions.
considered? There is one. Have you considered the use of RFID-based sensor for smart agriculture? Yeah, we are using RFID-based sensor for some applications. For some others, we cannot. For example, to measure temperature, we are using temperature sensor. But RFID is used a lot on the animal part, where I want to recognize each animal from another, or if I'm going to follow fruits and things like that. Yeah, RFID are also used in smart agriculture.
Okay, so thank you very much, Victor, for this nice presentation. Thank you all the attendees. Also, thank you to all you that have done questions to Victor's. So it's a very interesting subject, and more and more important, as Victor told, the humanity need food, and mainly in poor locations, the technology application is becoming also more and more important. So I think our community has a lot of to do to help to improve the quality of life around the world. And so thank you for this very interesting talk today, Victor. So thank you all. Before closing the session, I would like to invite all you also to attend the IEEE Sequencing System Society talks that are organized each Friday by the IEEE Sequencing Systems Society chapter Rio Grande do Sul. So if you go to the YouTube and you select IEEE Sequencing System Society Rio Grande do Sul. You can see a real-time talk each Friday. And also you have there more than 90 recorded talks done last year and this year. So thank you all you. Thank you again, Victor, for this very nice talk today. And see you in the next IoT initiative webinar next month. Bye-bye.
Thank you very much to everyone.
Bye.
Bye-bye. Thank you.
Bye.
Bye.
Bye-bye.
Bye. Thank you very much, Ricardo. Thanks
Thank
for
you,
sharing
Harry.
the session. Thank
Yeah.
you
Yeah.
very much.
And thank you both. That was really, really good. Lots of participation. It was wonderful.
Yeah.
Yeah, thank you.
So when the recorded version will be available?
That's a good question. So hang on a sec. Hang on a minute.